Hi everyone, so today we are going to pick back up on chapter 10.2, which is about comparing two means. And we talked a little bit about the conditions before we went on break for doing inference about a difference between two means, but we'll quickly go over that again today. And then we're going to actually construct and interpret a confidence interval for a difference between two means. So right before we went on break, we talked about the conditions for constructing this confidence interval for a difference of means, and it's your typical random condition, your typical 10%, and your normal large sample. So I am not going to go over this again because we mentioned it, but if you'd like to pause the video and reread through this, feel free to do so. All right, but we did go over this problem, and I do want to revisit this. And the reason is because I want you to make two lists of data, and I want you to take all the data in this portion here and put that in your L1 on your TI. And then I also want you to take all the data here, the 2-bedroom data. Sorry about this, I'm not doing a great job of circling this, but make that your L2. Okay, so make a list on your calculator with that data. 1 bedroom is L1, 2 bedroom is L2, and that's because that's the way we're going to define our interval. We're going to find the confidence interval for the difference between mu1 minus mu2. So make this your L1, make this your L2, type all your data in, and then I'll show you where to go from there. All right, so this was a problem on checking conditions, but again, I'm not going to go over that. What I want us to do really is make the confidence interval. Now just put your calculator to the side for now, because here is our formula for the confidence interval for mu1 minus mu2. Okay, as always, it starts off with your statistic or your point estimate plus minus some kind of critical value times the standard deviation or standard error of your statistic. Just as with the two proportion confidence intervals, typically starts off with you subtracting the statistic of one group versus the other. Here you're subtracting x bar 1 minus x bar 2. And remember, when working with means, we use the t-star critical values. Okay, so I like to call them t-scores. Okay, we use our t-table. That's whenever we're working with means. And here is the sample standard error right here. Okay, and it's our standard deviation 1 squared divided by n sub 1 plus standard deviation 2 squared divided by n sub 2. And these are the sample sizes. These are your two values of n for your individual independently random groups. All right, now right down here you're going to notice talks about the degrees of freedom again, because remember, with t-star critical values, we need to know the degrees of freedom. And there is a pretty complicated formula for degrees of freedom that I am going to not encourage that we use, and I am going to highly encourage that we use technology to find the confidence interval, just as we did in the last section on the intervals for the difference between two proportions. Okay, just trust me on this. It's a very, very complex formula. This other option, the smaller degrees of freedom of n sub 1 minus 1 and n sub 2 minus 1, is a very rough estimate and is oftentimes very far from the actual degrees of freedom. So since we have the technology, we're going to use it, and we are going to do this completely on our calculator. Okay, so the next slide here, we have, hopefully you have the data in your two lists. Remember, L1 was for the mean, L1 was for the apartment, 1-bedroom apartments near that college campus. L2 was for the 2-bedroom apartments. And you're going to look for the 2 sample t interval. Okay, you're going to hit your typical stat and tests, and you're going to scroll until you find the 2 sample t t-interval. Okay, don't accidentally click on the Z. But here you're going to input your data because you have entered two lists of data. Keep the frequency at 1 and 1. Use whatever sea level is given. Here it was 90%. Now you are always going to hit no for pooled. We'll talk more about that later in the week. Just say no to pooling here. Okay? I know we had to pool for hypothesis tests for P1 minus P2, but here just say no to the pooling. And when you calculate your TI should give you this interval right here, negative 144.8 to negative 11.2, which if you are calculating mu1 minus mu2 would indicate that mu2 is probably larger, because if you're taking a smaller number and subtracting it from a larger one, you're going to get a negative interval here. And this could just as easily be a positive interval if we had defined mu2, if we had defined the 2-bedroom ones in our L1. So we're just going based on the order that was given, and you'll see here are degrees of freedom. Notice it's not a whole number. It's going to be a decimal. And again, it's a very complex calculation that is just not necessary because we have the technology to do this. So DF 17.8975. Here are the 2x bars from the sample, and it does all the work for you. So highly encourage you to do this. All right, let's look at one more example. All right, so I'm going to quickly read through this, and we'll talk about how to set this up. So the Wade Tract Preserve in Georgia is an old growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is how do the sizes of longleaf pines in the northern and southern halves of the forest compare? To find out, researchers took random samples of 30 trees from each half and measured the diameter at breast height dBH in centimeters. Here are summary stats and comparative box plots of the data. Alright, so you're going to notice here that they didn't give you any data in, there's no list here, okay? So they actually gave us the summary stats. So they took 30 trees in this northern half and calculated a mean dBH of 23.70 centimeters with a standard deviation of 17.5 centimeters. In the southern half, they took 30 trees. They've got so these would be equivalent to your X bars right here. You have 2 X bars and you have 2 standard deviations. And if you look at your data here, this does look a little skewed to the left. Sorry, skewed to the right. This looks a little skewed to the left just based on the length of the whisker here. But since we've hit the magic number of 30, we satisfied the CLT, and that doesn't have any bearing at all on whether or not we can proceed. So we're good to go here. All right, but now let's get to the actual problem. Now, we're going to just construct and interpret a 90% confidence interval for the difference in the mean dBH of longleaf pines. And here we're going to go southern first and northern second. So I know you're seeing north written first here and south on the bottom, but basically we're going to set our southern portion as the mu1 and the northern portion would be our mu2. Okay, and that's basically to keep that confidence interval positive because I see this has a higher mean here and this has a lower one. So sometimes you may you may do that to keep the interval in a certain way, but sometimes it makes no difference. But here we're going to just go through our steps and see how this all works out. So we're going to state we want the 90% CI for mu1 minus mu2, where mu1 is equal to the true mean dBH of all trees in the southern half of the forest. Mu2 is the true mean dBH of all trees in the northern half of the forest. Again, if you're not told how to define your parameters, you can choose whatever order you want. Here, we're just going to follow the book's order of southern and northern. So mu1, mu2. If you want to label this as mu sub s, and maybe call this mu sub n, that would also be totally fine. All right, you can use little descriptors for your subscripts. All right, so now here's our plan portion. So we are going to use a 2-sample t interval for mu1 minus mu2. This is the name of the inference method. Our random condition is satisfied because in the problem prompt it said we have independent random samples of 30 trees, and they were each from those two different halves of the forest. 10% condition, we are going to do a little assuming here, and 30 should be less than 10% of all trees in the northern half of that forest, and likewise for the southern half. Now our normal large sample down here, remember our samples for each group hit that magic number of 30. So we technically don't need to look at the graph of the sample data. Here it was given, and if it is less than 30, then you are going to have to graph it on your own and just check for outliers or strong skewness. Okay, here's our do step. So, like I said, I am going to highly recommend you use technology. If you'd like to calculate it by hand, you saw the formula on a previous slide, and you can do so. But I'm going to highly encourage us to use the calculator method, and I'm going to skip right over here. But notice that we get 3.83 to 17.83, and they're using a degrees of freedom of 29, which are, as you're going to see, is a very conservative estimate here. But you'll notice the actual degrees of freedom are not even close to that. So here, going on the do step, using our TI, using a 2-sample t interval, you want to write your 2-sample means here. So I have x bar 1 and x bar 2. And I have our 2-sample standard deviations and our 2 sample sizes. And the calculator is going to output 3.9362 and 17.724. And it's going to tell you the degrees of freedom are 55.728. Okay, so here's what the screen looks like. Instead of inputting data, because you don't have the list of the actual data and you have the stats, you're gonna highlight stats. So you go stat test, find the 2-sample t interval. Okay, don't go to 2-sample t test either. We're not ready for hypothesis test yet. Go to stats, input the data that's given, x bar 1, standard deviation 1, sample size 1, x bar 2, standard deviation 2, sample size 2. We wanted a 90% confidence interval. Just say no to pooling. We'll talk more about that later. And here's your confidence interval. And again, the degrees of freedom, 55.727. That is also something you want to report. All right, so to conclude, we are 90% confident that the interval from 3.9362 to 17.724 centimeters captures the true difference in the mean DBH of all the southern trees and the true mean DBH of all the northern trees. All right, so here your conclusion can be worded. You could say captures a true mean difference in DBH of all the trees in the southern and northern halves of the forest. You could say that instead of saying true mean twice. All right, and the very last part here is just a little AP exam tip. So just talks about what you should do when you're using the calculator. Talk about the procedure, 2-sample t interval, and the plan step. Give the actual interval, and then give the degrees of freedom in the do step. It wouldn't hurt to also give the x bar 1 and your x bar 2 and your standard deviation 1. Wouldn't hurt to give those as well. All right, we'll talk about significance test tomorrow. That's it for today. Have a great day, everyone.